So, hello everybody. We gave people 5 minutes. We increased turnout since by 50%. I'm just saying this because this is a statistics session. So, uh, hi everybody. Welcome. I'm Levi Litvai, and I am from the Center for Social Sciences in Budapest, Hungary. I'm also affiliated with Central European University's Democracy Institute. And probably most importantly, I'm one of the founders of MethodsNet and the person who has been responsible for quantitative research. Currently, most of my research revolves around artificial intelligence and how to have artificial intelligence assist public opinion research. That yeah, that is mostly at the center of it. I have been historically quite a technology geek, and I have been extremely bored in the past 10 years because nothing happened. And suddenly, with artificial intelligence and large language models proliferating, there's some fun stuff, and I think it is going to be transformative for the sciences. For better or worse, I'm actually looking at both sides for the things where it will be making it worse, and that we'll have to deal with, and where it will be making it better. But one of the questions that emerged to me as I was using artificial intelligence for my own work in research and statistics was how is this going to transform education of introductory statistics? So basically, I have always been a person who said if you learn the statistics well, the rest is simple because then you can just open a manual for software, and if you want to use this software or that software, it's perfectly fine. It's there's no issues there. That was a lie because the software manuals are difficult to understand, but still, if you know what you're doing, you can probably figure out the software side of it. Today, you can not only figure out the software side of things, if you just know what you want to do, you put that into any of the AI models that are contemporary and available today, literally any, they'll do it for you. And that led to the question of where does that leave us? So I've been developing a program where we would be learning statistics from an introductory point of view, but we would be doing it through the assistance of artificial intelligence. So we're going to try to get the good out of the AI and not just the bad. So we're going to try to squeeze the benefits out of this. Now, I have to tell you that this is quite experimental. I have done this to study text, so content analysis, text analysis, and I have done this for a little bit for statistics, introductory statistics, but very preliminary compared to what I'm planning at MethodsNet. So there I'm going to have a course in the second week of the MethodsNet summer school. I'm going to have a course called Statistical Analysis Basics in the Age of Artificial Intelligence and Large Language Models, and it's going to be a workshop. So we're going to be able to fit a lot of content. This course is predominantly intended for two groups. One group is the people who have not worked with statistical analysis but would like to. Um, I expect researchers to be showing up at these. This is mostly aimed at least masters, but more PhD students and postdocs. Our events are generally aimed at PhD students and postdocs in the social sciences. So if you have been a researcher and you work with quantitative researchers, or you just want to understand the basics of quantitative research and you want to be treated as a researcher while learning the basics, then this workshop is for you. The other group that I've been aiming my introductory workshops to are people who are starting to do more advanced things but feel like they are missing some foundations. And this happens very often, I have to say, in the social sciences where certain foundations are not taught well enough. You very quickly get to a place where you can run regressions and maybe even more advanced models. And a lot of these people are like feeling like I'm missing something. I'm missing some basics. So these are the two target audiences for the class. Now, I want to make this a little bit interactive. It's not going to be very easy because all we can do to interact is the raise hand function. So I'm going to raise my hand now, my digital hand, and I'm going to lower it. So let's try this. Are you one of these two groups? So are you the group who would need to learn the basics of statistics? Your research you would need to learn the basics of statistics. Yeah, we got one person, and we've got three, four. Okay, and then we've got 40 people who can't find the button, right? All right, everybody put up their hand. Let's see how many of you can find the button. Let's do it this way. So okay. The majority has done this. So with this majority, Viktor Orban would still win the election, but okay. Okay, so that's good. You found the button. So let's put it down now. Put it down. So let's do the other group. Are you the group who have been using more advanced models, regressions, or more advanced models, and feel like you're missing some foundations? Maybe you're one of these people. There's a lot of people here who need my course, I have to say. So so. Okay. Well, that looks good. Anybody's here because you're predominantly some AI enthusiast, or you would want to see how you can use AI? Put your hand up. Okay. Okay. Not bad. All right. So let me introduce this course. I think any of you think you've got this down, like statistics you have, you're just here because you're curious. Anybody? Okay, that's good. It's good. A couple people. Hi, Dennis. I know you. So, okay. So that's not bad. So of the four people or five people who put up their hand, you probably have heard of a statistical concept that we'll cover in the workshop as well. But I wanted to introduce what how I'm thinking about this with like one little slice of statistics that I think is important. So central limit theorem is one of these things that I think most people don't fully get. It's difficult to get. I fully admit it. It basically means that central limit theorem says that the distribution of sample means are going to be normally distributed. Now, what does that even mean, right? Uh, what it means is that no matter what a variable looks like in the population, when you sample from that variable, when you sample like smaller samples from that population, and you do it over and over and over and over and over again, the means of those samples that you have pulled are going to be normally distributed. Well, let me show you how this looks like in reality. Like, what's the struggle that most people usually struggle with when you're looking at this topic? So this is a Z table. I could have put up the T table. This is something we use in statistics. So um, this is the normal distribution, and then what the question we're asking is where do you fall on this distribution in the various statistical tests that we ask. And I don't want to get into the details of this. I will in the course, of course, but I don't want to get into the details of this. But a lot of us end up wondering, like, why is this normal distribution assumed? Like everything we work with, none of it is perfectly normal. Why is this normal distribution assumed? That is the question on anybody's mind. So, show of hands, has this been a question on your mind, possibly? Let's see if is this something that you've been asking yourself? Yeah, there are a couple people. Okay, so it wasn't a complete miss. All right. The answer to this is central limit theorem because the distribution of sample means are normally distributed given that the sample size is large enough. That is the explanation you get in most statistics classes. In some statistics classes, that is followed by a bunch of math that nobody but the teacher, but probably not even the teacher understands. So at least in social science classes, that's what I would say. So let me show you what we can do when we start outsourcing the difficulty associated with when we start outsourcing the difficulty that's associated with programming and coding, that's always like a barrier to entry. In the classroom, you get a bunch of math. In the other classroom, you have to learn a bunch of programming. Both of these are hard. Today, it's not hard anymore. So let me show you what we can do if we can break this barrier. So I have shared my screen. This is a program called Positron. Has anybody heard of RStudio? Hands up if you heard of RStudio. All right. All right. So a lot of you have heard of RStudio. Okay. Put your hands down. Hands up if you use RStudio. Okay. A lot of you use RStudio. All right, put your hands down. What you need to do now is delete your RStudio because RStudio is dead. The people who have developed RStudio have said, we can't do this anymore. We need a new program. And that's what you're looking at right now. This is called Positron. It's developed by the RStudio people, but they have recognized that they need to move to a different interface, a different logic, even though it looks very much like RStudio. They need to move to a different modality to be able to incorporate all this artificial intelligence assisted coding into their platform. So what you're looking at now is the successor of RStudio. Might as well start using it today. It takes some getting used to, but not much. It's fairly comfortable to use, I have to say. I like it. It took a few weeks, but I like it. So what I'm going to do now is this is just like RStudio. Like you can code over here if you know how to code. This is where you're running your models, etc. This is where you have your environment. This is where we find your plots, and this is the files you're working with. This might be new. You might not be. You might only be used to the four panels. The four panels are the same. So what I'm going to do now is add a fifth panel that is an artificial intelligence student. I'm going to use Claude Code just because I think it's the best, but I'm not going to be using Claude Code for the class. And the reason I'm not going to use Claude Code for the class is because it's expensive. But there are other alternative, free alternatives, which I am going to be favoring in my class. And the reason I haven't selected which one yet is because I just haven't made up my mind. So, okay, I accidentally hit the debug console, but okay, we don't need that. That's new to me. I want to make this just a little bit bigger. All right. So, here's what changed. So far over here, we had to code what we want to code. Right now, all we need to do is in plain English, we need to ask Claude to do this coding for us. I've created a file, I called it working.r, and we can just say, okay, I want to demo central limit theorem. All right, that's what I promised I will show you. I want to demonstrate central limit theorem. And for this, I need uh, three populations. I need a normal one, a bimodal one, and a skewed one. Let's make the sample size 100,000. That would be a good population. That's almost the population of Montenegro. That was the running joke at Central European University that you could almost survey everybody in the country. I had two PhD students from Montenegro. That was and they have been teaching assistants at various method schools that I've been. So that was the running joke. So this is what we're going to need. We need to put this into a data frame for future use. Okay. Um, yeah, I'm gonna hit enter. This is good. Now let's see what it does. I can already see, oh no, it has figured out that there's a working.r file. It has started writing in the working.r file. It has generated code. So good. Now I am going to say that it can always write on this file. So I'm going to approve that. And then I'm going to tell it that I don't know statistics very well. So please comment in detail in the code what you are doing. All right, there's another command. You see, it has already written the code, doing what I asked it to do. So you don't have to do it, but it doesn't tell me what it's doing. Now we're going to change that. All right. Takes a second. Sometimes it's a bit slow, but there you go. Central limit theorem demo, step one, build three populations, a normal bell-shaped population, a bimodal population, etc., etc. It tells us that it has set a seed. This is important, that if you want to reproduce if you want reproducible data, then this is important, because next time you run it, it would be very different. We're going to have population sizes of 100,000. It explains that as well. It did a mean of 50 and a standard deviation of 10 for our data. Let's change that. I don't like that. Okay. So let's make sure all populations have a mean of 0 and a standard deviation uh, of 1. There you go. Give it a second. So I want it to be comparable. By the way, just moving on, it has produced the bimodal distribution. It explains how it does it. It does by doing a one normal distribution and another normal distribution. And and then it has produced the skewed distribution that's like not a normal distribution, but a distribution leaning one way or the other. All right. So it has done everything we asked it to do. It is producing the data set with these three variables, the three populations. Um, Sanity check, so it actually checks itself. So yeah, why don't we run this and take a look of what we get? Well, we obviously have some new data sets here, and it has produced some data sets which have it has some, yeah, the distributions, the means are 0. The standard deviations are it has the minimums and maximums here. We can probably do better. So let's plot the three distributions. Um, okay, let's plot the three distributions one at a time. Otherwise, it's going to make these panels that are hard to read. One at a time. In addition to the histogram, add the theoretical distribution for comparison with mean of 0 and standard deviation of 1. All right. So it has produced the data, but we want to check it. So what's the best way to check it? It's the best way to visualize it. All right. it is thinking through this right now, and we have all the plots. It's explaining how it's plotting. Normally, I would go through this, but we're not going to do that. It has used a plotting function that I don't like. When I tested this earlier today, it didn't do that. So that's the nature of working with AI. Uh, I'm just gonna say use ggplot instead. I think it makes nicer plots. That's something you have to know. All right, it's going to be updating this. I suspect what it did would have worked as well. All right. All right. So let's see what these plots look like. There you go. Beautiful. Beautiful. Here's the three plots. This is the normal distribution that we produced. And the red line shows you what a normal distribution should look like. That is a perfect match, isn't it? Here's the bimodal distribution, which has two, uh, there's almost nobody in the middle and it has two humps. So that is very much deviating from the normal distribution. And here's the skewed distribution, which is like just pulling a little bit away from the normal. I don't think this is skewed enough. Uh, can you make the skew distribution more skewed? We're going to make it more skewed. I don't think this is extreme enough to demonstrate what we want to demonstrate. All right. I also don't like this baby blue color. I'm not a big fan of blue. Can you make the histogram uh, forest green? All right. Yeah. All right. So I'm gonna clear these figures here. I'm gonna run the whole thing again. Beautiful. Yeah, that's a little bit better for skewed distribution. Uh, maybe even a little bit more. Later this will be important. Yeah, but this is beautiful. We have a perfectly normal distribution, and then we have this weird distribution that does not follow the normal distribution at all. So you would ask, how can we use this? How can we use this with the z table, with the t table? We have this very skewed distribution, which is going to be even more skewed when I rerun this. And it's a fair question to ask. How can we use this in okay, this is perfect. Yeah, how and why can we use this as part of in a statistical analysis? All right. So to demonstrate this, I am going to ask to draw samples from this population. Because what we usually do work with in statistics is not the whole population. We are usually working with samples. So we are going to be drawing a sample now. So to demo central limit theorem, let's draw let's say 200 samples from these populations, okay? And plot their sample means. Use a separate plot for each, use a separate plot for each of the populations where the plot should have two panels, the population distribution on the top and the histogram without the red line on the bottom. And the histogram without the red line of the sample means on the bottom. Sample with, we're just going to do a very small sample. So we're just going to do 3. It's very small. Central limit theorem says that you need the, as you go bigger and bigger sample, you're going to have normal distributions of those samples. So let's see what it does. Again, dealing with AI, I don't know what we're going to get. I've done this before. We've already gotten somewhat different results. We can get somewhat different results again, but I am confident that it will either do this well, or I can tell it how to fix it. All right. So let's take a look at what it wrote. So here we define we're going to be drawing 200 samples with sample sizes of 3. It's very nice that it specified this separately. It's very nice that it specified this separately because then we can change this, and that is going to be what we're going to do. Um, so so there you go. Let's see what this looks like. Oh, it's perfect. Almost perfect. So there you go. So here we have the normal distribution in the populations. And then when we start uh, drawing samples from this population, just very small samples of 3. So that you would never do that in statistics or anything. You start drawing these samples of 3, you get a normal distribution of the sample means, and you might notice that distribution is actually getting a little bit narrower than the population distribution. So even with very, very small samples, you're starting to gain a little bit of precision. Let's look at the bimodal. Look at that. I mean, you still see the 2 modes, but it's almost becoming normal. You see that there's still a little dip in the middle, but it's looking better. Let's look at this one. It is starting to look better. I'm just going to change this 3 to 10. And let's run this again. So if we have sample sizes of 10, suddenly, look at that. How much precision we gain over just the population. Look at this. Perfectly normal distribution already for the bimodal and for the skew. There's a little bit of skew here, but it's already becoming a very nice distribution. Finally, let's just go up just a little bit for demonstration purposes. So we're going to draw samples of 25. Okay, just going to run it. And look at that. The distribution has disappeared. The distribution has disappeared. Let's go down a little bit. Let's do because the bars are so narrow, I cannot display it on the screen while sharing. But how about we go back to 20? And I think that'll work. At least that worked earlier today. And maybe I can make that plot a little bit bigger. Okay. Yeah, okay. So this normal distribution like looks almost perfect. This is a perfectly normal distribution. It's pretty light because of the problem explained and barely visible. So I am going to, there you go, make it a little bit bigger. There you go. So the reason, to answer the original question that some of you said that you had this question before, to answer the original question is that when you are not dealing with the original distribution, but we are dealing with samples, what the Z table and the T table does for us is that it tells us how likely is a sample. Now, if we go back, let's go to one of the earlier plots that have better visibility. Uh, there you go. Let's do this one. When you sample from this population, this is not normal at all. It's in fact quite the opposite in many ways. When you sample from this and you calculate a sample mean, you are going to have you can expect a fully normal distribution statistically. So if you if we take a sample, well, it might be over here, it might be over here, it might be over here, but we know it will have a normal distribution. And we know that on average it's going to approximate the population mean, no matter the distribution of the population. And the Z table, what that tells us is what's the probability of getting something out here, and what's the probability of getting something here in the closer to the middle, to the correct estimate, and what's the probability of getting something here. And because of this, we can assume a normal distribution as long as you have a big enough sample, and big enough, as you already have seen, is 20 25, 30, etc., for most distributions that you would encounter in most of the social, but also the medical sciences. So, this is just a teaser of what's possible and how much power can you squeeze out of artificial intelligence to demonstrate things that were very, very hard to demonstrate. I am designing a course for the summer that is going to go through the concept. It's going to go through some math too. It's going to go through the topics, but it is going to try to leverage the power of artificial intelligence to demonstrate and leverage the power of artificial intelligence to analyze real social science data examples. And what I want to do is I want to get up to at least the level of regressions in the workshop so that everybody who starts, you can start from nothing. You can start from weak foundations or nothing, and we'll get you up to the point where you will be able to understand regressions well. You're going to understand the concepts because of such demonstrations as this one. Not 30-minute one, not so quick ones, but that is the goal. And when we're done, we're going to, if we have time left, then we're going to be working a little bit with text as well. So I'm going to be able to show you some basic text analysis as well, using the same tools and the same approach. All right. This is what I had prepared for you. I think this is very representative of what I'm hoping to cover. And at this point, I would be very happy to stop sharing and look at the Q&A. So if you have any questions, start throwing questions into the Q&A. I'm asking Anna and Catalina that how are we doing the Q&A sections usually at these events? I see. Please submit your questions in the Q&A box. You could feel free to ask about things that are broader than what I've covered. About the approach, about pedagogy in this age, uh, the 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 good things and bad things about artificial intelligence. Um, I would argue that you should learn statistics. If you have questions about that, you feel free to ask. This is super weird that you're not here. I can't see you. So, um, can I demonstrate anything with text? I haven't prepared anything with text, but I can tell you what I did demonstrate when I tried to do this before. I have done a workshop. So actually, after this, at 3, my class is starting at the Invisible University for Ukraine. At Central European University, we have a program that is trying to normalize the life of university students who have been scattered all over Europe and try to offer some education while their universities are closed. And in that program, I was asked to do something on text. And what I did was I went through kind of the progression of how text have been used in political, how text analysis have been used in political science, starting from just simple word counting, going to word clouds, going to um, trying to get like measurement in text of certain things based on dictionaries, then go to scaling models, then go to topic models, and et cetera, et cetera. So we went through all of that in theory, and then I pulled up this, what this little thing in front of me. In fact, it wasn't even this. I was just copying and pasting with ChatGPT at the time. Between RStudio and ChatGPT, but this would be even easier and more powerful. And I grabbed the data set that was very simple to compile. I took the US president's inauguration speeches from Jimmy Carter all the way to Donald Trump, actually Joe Biden, actually. He this was before the second election of Donald Trump. And and just using that corpus, that data, I said, well, let's try to do these things. Let's get word clouds. Let's take a look at how many times the presidents say America. And they just went step by step and had R do that analysis. And it was trial and error. It was a lot of trial and error. I think it was a lot more than what we've seen over here with this statistical analysis. But we were able to go through all those things. So I'm planning something similar for the class as well, maybe a little bit more in depth. Maybe I'll think of some better text, and well, that's the idea. But honestly, if you want to play with a tool like this, there are two tools I would recommend for you. I'm going to share my screen again with the browser. Uh, Give me 1 second. There are two tools I am considering for the class right now. Uh, one is uh, one is called Open Code. Mm, OpenCode.ai. OpenCode is very similar to Cloud Code that I just showed you. And they always offer some free model in there. That's usually good enough. They offer that because these models, when the models that are given to them, these AI models that are given to them are I mean, they use the data that you produce just by playing around for training and etc. So it's a benefit to the companies developing these AIs as well. So it's but they offer something good for free. And before I make up my mind, which might actually be just a day or two before the class of what we're going to use, I want to see what's available and what kind of commitments do they have, how long it will be available in this tool. But we might actually be using open code for the class. So you can just download this and you can open it up in a terminal. You can open it up in Positron. There's an extension in Positron. So if you go to Positron, I wish I could remember where it is. I think this one, yeah. So you can just say open code. It'll find it. Yeah, there it is. Open code extension. You install open code, and just like we use Cloud Code over here, you can just be using open code over here in Positron. And the other one that I actually really like is called Mistral Vibe. Mistral is the biggest European AI company and is producing very, very good products from at least my perspective as an AI researcher. It doesn't beat Claude or it doesn't beat ChatGPT, but they have a free tool. Right now it's free. I don't know if it's going to be free when we when we get to the class, and they have a code. You can just download this, register on their website, and you can use that as well. So Honestly, you could just go home and try these things yourself. You can experiment with this. And I would encourage you to experiment with this because this is the future, unfortunately, or fortunately, depending on your point of view. So yeah. Okay, I see questions. Give me a second. Let me pull up the Q&A. Actually, let me make the this disappear. Okay. Um, let's say the place of AI in our methods courses is on a continuum. The cookie question is uh, where should we place the cursor in your opinion? I believe the same thing that I've believed for the past 20 years of teaching quantitative methods. And that is very, very precisely and specifically that if you know what you're doing, the application of the statistics is super easy. It was somewhat a lie before because manual diving in the R manual is painful, but now with these tools, it is going to be super easy. So I do struggle with the question of if somebody wants to learn how to use R today, what's the best way of teaching that? That I struggle with. On the other hand, I don't struggle with if we want to teach statistics to somebody, to social science statistics or quantitative analysis for the social sciences, what I need to teach is the exact same thing that I've taught for 20 years that gets you to a place where you know what you're doing and the application has just become absolutely trivial. So far, I said it's easy even though I didn't fully believe that. Today, the application is absolutely trivial. And I think we just need to use that. We need to know what we're doing. We need to learn R enough so that we can audit these tricks that actually I was already showing you throughout the demonstration of how you need to incorporate a lot of make it comment the code so it explains every step of the way what it's doing. That's very helpful. You do need to audit a lot more than we have in this time, and we'll be doing a lot more audits in class. But that's where I would place the cursor of in between how much AI should we have in our methods courses. And same for qualitative analysis. I think AI can be a very, very powerful qualitative analysis tool as long as you know what you're doing, you're auditing what it's doing. Uh, um, it's a great resource. So that's where I would be. With qualitative classes, there's another concern is you need to understand the legality of data management and data privacy. So you need to get a little bit more invested in that because it's just not what I did now of using Claude with private sensitive data like an interview. That's not okay. You will need to develop different ways of approaching that, but there are good ways of approaching that already. You can, with appropriate consumer grade hardware, you can run AIs locally and they're perfectly capable of the kind of analysis that you might want to do. In fact, I built systems like that already just for the fun of it, just to be able to say that I've done it and I've tried it. So yeah. Kevin, great question. Thanks. Peter, great webinar. Thanks. No, thank you. Um, what should be the balance between learning the standard coding and AI coding? Okay, so that's the question that I still struggle with. Um, for students with no coding background, yes, that if you figure it out, let me know, because your worry is my worry as well. I have never been very good at teaching the coding. I always placed a stronger emphasis on concepts and a stronger emphasis on understanding what you're doing and not necessarily mathematically understanding, because very few of us in the social sciences are mathematical minded. But understanding really what you're doing is what I think is the most important thing. Um, because I haven't taught that much coding, or when I have, it was mostly with a focus on the stats and the concept and the application. I always just like by the way, this is the application, but I mean, if you can read a manual, you can figure it out as long as you know what you're doing. That was my approach. But this question is in my mind is I don't know how we can teach coding in the age of AI when the AI is coding, or how much we need to teach coding. Um, One interesting thing I can tell you running MethodStat is that there seems to be still a great demand for courses on R and courses on Python. And that's what I'm seeing from all the method schools around. I talk to the people teaching these courses. I'm asking if their registrations are dropping, and they're not. And most of the people I talk to who are teaching, they're teaching like AI doesn't exist. So they're teaching the same thing they've taught 5 years ago. And that might be the answer. I don't know. Um, Talk about the disadvantages of text analysis compared to human reading. Um, I am going to reverse that. Text analysis, quantitative text analysis is a very superficial way of reading. Uh, its advantage is that you can use it with massive quantities of data. So I have worked with thousands of speeches. I have a colleague now. We're working together on everything that's ever been said in any European parliament since the time they started recording it. That is not something any human can read in one lifetime. So we trade off the strict understanding for the strict understanding we trade off for a much more superficial analysis, but of a lot more data, and that's a trade-off. I don't think of this as a pros and cons. It's just different ways of doing things. Large language models are interesting in a way because they can do deeper reading than these classical text and analytic approaches. And we have the opportunity of getting the deeper meaning out of text through these large language models. We just need to figure out how to ask our questions in this new modality, research modality. But this is something I'm actually quite excited about. I think there's some great opportunities here. This is a good time to be a text analyst, to be honest. Of course, nothing replaces human reading, close reading. You just cannot do that on mass quantities of text. Um, Limit to the complexity that our studio's AI can handle. How can I identify a faulty code? And what is my take of delegating responsibility to AI, especially when trying out new methods? Great questions. I believe this is gonna be radical, but I believe that that there is enough evidence to say that there are no limits to AI's ability to code. We have enough evidence to know that AI codes better than humans, period. So there are no limits there. Um, but there might be something lost in the communication. So when you are explaining in plain English what you want and the AI is coding it up, there might be things lost in the translation. And I have experienced this over and over again. And the only way around it is continuous audit, continuous audit, continuous audit. You need to check what the AI is doing. And when you don't understand, you need to have the AI explain it to you. And mistakes will still happen, but I would argue that mistakes happen anyway, especially if you think in terms of like coding teams, where you're responsible for, let's say, a lead engineer is responsible for like 15 coders. The same kinds of mistakes happen anyway. Um, so. I think a lot of the problem in these kinds of questions and evaluations, not just of AI, but everything, is sometimes we take status quo as perfection. Like as compared to absolute perfection, how good is AI? Well, AI is very shitty compared to absolute perfection. But if I compare AI to a team of junior engineers, it's much better. So, so my ability to explain to the junior engineers and might actually be worse than explaining to the AI. So that's kind of the trade-off and the comparison we need to switch our minds to in these cases. Um, do you know about situations regarding data protection when using coding environment that includes a interface when using sensitive data? Yes, absolutely. You can. You absolutely should not use these environments when you're using sensitive data. So I want to make that clear. But even going beyond, you need to think about the European laws of GDPR require us to never export sensitive data, never hand over ownership of sensitive data, and and if you just upload it into Dropbox or Google Drive or even Microsoft OneDrive, that is a potential misuse of sensitive data. So usually my approach to addressing this question is to make sure that people understand what is your responsibility when using sensitive data. Sending it in your Gmail is the exact same thing as sending it to Gemini, the AI tool. So once you develop an appreciation of what it means to export sensitive data, um, you will be able to apply it universally, and AI will not be a special category in your head of what about these things for AI. The good news is that while it's quite hard to host your own email service, your university might do it for you, and they might do it, and should, they definitely are doing it in a safe, legal way. Um, you can host your own AI models. They will not be as smart as let's say Claude that we just used, but they'll be good enough for most things most of the time. So if you buy a more powerful Mac, let's say you buy a top of the line Mac Mini, I know it's not cheap, it's like 2, 3 thousand euros. You can run AI models on that thing locally, and and your data doesn't go anywhere. It's all calculated on your machine, and that can be set up. You can use it. I showed you Claude Code. Claude Code ties in with your locally run models as well. So you could just use not Claude Code, sorry, Open Code. So you could just take Open Code, which is what I showed you earlier, and you can tie that to your local running of your large language models, and then everything would be able to run locally. I am literally waiting for the release of the M5 Mac Minis because I'm going to buy a top of the line Mac Mini so I can do a lot of these things locally myself. I'm just not going to buy the current model because I know a new one's coming in like 2 months. So I'm holding off. We also have our university does, or that my university doesn't, but there are universities that does provide service of safely and legally using AI, privately using AI through their services, through the contracts with various service providers, that doesn't go to training and doesn't go to OpenAI or other data providers. And sometimes institutions like mine can actually run their own servers to do this. Well, I am running our own servers myself because I'm head of them, but I'm already providing this service to many of my colleagues at my institution. So if they need private AI, we built it and they can use it. So they just need to ask me, and that's it. So this is completely doable. And again, if any of you are interested in this, just shoot me an email. I'm happy to respond. I'm not gonna promise I'll be quick, but I'll respond, and I can be more specific, give you some resources. what you do need is a good computer. That is a must. Is the need for like in the past 10 years, like there was no point in upgrading computers because everything just worked. Now, if you want to do any of these local AI things, you're gonna need a very powerful computer that's gonna cost like three, four, five times what you're used to paying. That's the caveat. All right, great questions. Great questions. Well, I hope this teaser was able to um, get you interested in the course. And if you think anybody would benefit from it, please tell your friends. Registration is only open for a couple more days. And yeah, so if you're interested, please sign up. If you know somebody who would be interested based on this, please ask them to sign up. And if you have a question for me, shoot me an email. Happy to respond. I won't promise I'll be quick, but I'll respond. And thank you for coming and thank you for your time.